วัสดีครับก็วันนี้จะเป็น presentation ครั้งสุดท้ายของวิชา SC135 นะครับโอเค let's start so okay this is gonna be the last presentation of the SC135 physics subject okay let's talk about the last presentation that I previously told you about okay the last presentation that told you that I'm going to bring the electric turbocharger into the main subject because this is a new kind of a technology that can change the whole world of the automotive field. Okay, the interesting thing about the electric turbocharger that you can see here, this is a Formula 1 car, or we usually say that like F1 car. Okay, I choose this topic because that F1 car using electric turbo right now. Okay, electric turbo is a new future for turbocharger that's invented for a century. It might be a few ways to develop to use combination with electric motor recently. Mercedes-AMG is serious about bringing Formula 1 technology to the street, something it made evident when it reviewed its race car like one hypercar. Now Mercedes is taking more of its F1 research from the track to the street. Mercedes has been using electric turbocharging on its F1 car for a few years now, and is confident it will be able to implement it on the road car. Actually guys, Formula 1 car just use this kind of technology just like 1 year, because that the engineering of the Mercedes is very clever. They want to bring the electric turbocharger on the street, not only on the Formula 1 car anymore, because that it has a lot of advantage. As I told you, that it's like first of all, you can save fuel consumption. Second, you have a lot of power because you're using the electric too. Okay, the second paragraph is all about the detail about the engine. Okay, let's read it. Currently, the M139 engine offers a maximum 414 horsepower and 369 of torque, and those numbers are likely to change as a result of the electric turbocharger. Instead, what will change is how the engine delivers that power, because the turbocharger doesn't stop spinning. It will develop better torque in the lower left range, as well as increase total response. Okay, when you want more torque, you initially think about diesel engine, but when you want about more horsepower, you're thinking about the gasoline engine. Okay, so here this is it. In between of you want more torque, you want more horsepower, you just push the electric turbocharger. Okay, and the third paragraph is seems to be possible to bring electric turbocharger in technology of the F1 car to the street car use. Okay, so this is my proposed work and methodology. Okay, the situation here right now, as there are many types of turbocharger in 2020, electric turbo just introduced by Garrett Motion. It is a new technology to change the world. Garrett Motion is the company that introduced us the electric turbocharger, or who invented. And proposed solution, electric turbocharger had a duty to change the world by their benefit. There are downspeeding, downsizing, and high efficiency aerodynamic. So these are the bobs of it, the three kind. That is very benefit about the electric turbocharger and other kind of turbocharger. Okay, step involved. I have three steps. First, need to understand of how the system works. Second, distinguish type of turbocharger. And third is adapting types of turbocharger for appropriate use. So what is your benefit of knowing these three how? First thing, the benefit is improving knowledge skill. Second, electric turbocharger can reduce emission. Okay, so are there any obstacle? Yes, there are two of that. First thing, it would be high cost for bringing the electric turbocharger or the other kind of the turbocharger to have the research, because it need to spend a lot of cost. And second is it would be difficult to do experiment on every turbocharger because it needs to find appropriate engine ICE to test with this. So this sentence is really mean that we're gonna take example of variable geometry turbocharger. That variable geometry turbocharger incapable of using the diesel engine, but if you want to use with the gasoline engine, we'll take the example of the Porsche 977 if I recall. So it would take a lot of cost to do the experiment on it. Okay, next, system architecture. Okay, this one are the system that I used it to talk about on the last video. Okay, the system architecture, there are two of it that I'm presenting right now: increase power, decrease fuel consumption, eliminate delay, and boost commerce faster. Okay, this is how the turbocharger look like inside. We cut it in half and see how it look. So as you can see that this is VGT, variable geometry turbo. You can see the bed here. This bed will go up. Will go down and up, go down and up. In response of the amount of the oxygen or the amount of the air go inside the turbine compressor. And the right picture is show the system, how does it work. So when you drive a car, you just constantly I'm gonna say like this: when you drive the car goes straight with the constant speed. The turbocharger would not be work, but if you push the acceleration more harder, the compressor turbine will spin due to the amount of air get inside into the turbine. So in the result, the oxygen will go to the or we can say the intercooler, and the air will go into the engine by the intake manifold, and the crankshaft will combust the what do we call the emission, the emission out of the exhaust turbine. And next, this one is a twin scroll turbocharger. In terms of using a twin scroll turbocharger, you have to change the intake manifold to fit with the twin scroll turbocharger. And the right picture is single turbocharger. So not very complicated. You can see that how the simple things work. You can see the side here. Oh, sorry, this is not a single turbocharger, this is a twin scope turbocharger. Okay, so the air get inside here, the turbo compressor. Oh, wait a minute. Oh, this is the exhaust turbine here. Compressor turbine here. Okay, first the air get inside, and the other air go to the intercooler, and when it combusts out of the engine, the air will go here and go out to the exhaust turbine and go to the exhaust to release the emission. Okay. Wait a minute. Okay. So this is the electric turbocharger. Yeah, two of it is a electric turbocharger. Not anything complicated. This one is a bypass valve, and this one is wastegate valve or exhaust turbine. Okay, on the right side you can see that the electric turbocharger use the electric controller, and the power of it using by the 48-volt battery. Okay, this is how the system design. The system design here. This is the intercooler, and this is the wastegate valve, and this one is the electric turbocharger, and the left one, what wastegate here? Oh yeah. Sorry. This one is exhaust valve, and this one is electric turbocharger. Yeah. So there are 6 key of benefit using the electric turbocharger. First, enhance transist boost response. Second, reduce emission level. Third is enable downsizing without turbo lag. And fourth is enhance low end torque. And fifth, enable for the further down speeding. And sixth is reduce the fuel consumption. Okay, using the electric turbocharger on the BMW N57 engine, you can see that there are 4 kinds of the PSI that using with the electric turbocharger. For the graph, you will see that there are totally don't have any lag of the car. The green, yellow, pink, and blue continuously increasing to the top. Okay, and this graph show the acceleration and boost to understand of lagging electric turbocharger. So in the end, they are still have the lagging in the electric turbocharger, but very less compared to the other turbocharger. This one acceleration on the blue, and on the red is a boost when the boost comes. When you put the acceleration higher and higher, the boost will come much faster and faster. On the gap here is the turbo lagging. But it's still increasing continuously. Okay, system analysis here is talking about the 5 equations that using with the turbocharger. So this is a wind power equation. When you can get the power, you have to get all these number right. 1.5 multiply P multiply pi multiply R square multiply CP multiply CF multiply V power 3 multiply NG multiply NB. Okay, P stand for the power, and R stand for the radius, and CP stand for the power coefficient, and CF stand for the capacity factor, and V stand for the velocity, and NG and NB stand for generator efficiency and gearbox efficiency. Okay, on the second equation, you have to use the power law. KE equal to 1/2 mv square. Okay, let's go to the third one. Third one is an equation to find the mass of airflow to the wind turbine. This is a turbine. This is the, what do we call, a pipe? Yeah. You can see that this one has smaller circumference compared to the right one. The right one has a bigger circumference. And in order to know the mass of airflow, you will have to use the equation m equal to AV and equal to AVB and equal to A2VD. A is the area and V is the velocity. You can use 3 of this area to get this equation. And same thing here, power exact by the turbine, P equal to 1/2 m and different by 2 velocity from the last one and the beginning one. And fourth is the Benelli. Oh, this is the fifth one, and this is a Benelli equation. Benelli equation can study in the thermodynamic or fluid. Yeah. Okay. This one is very easy to explain. This is the pipeline or the valve. Sorry. I will go and get the word for it. Yeah. Bypass valve. Sorry. Okay, you have to use this equation to get the Benelli equation. And I hope that this project will be helpful to our reader. To our reader. This is gathering all information about the turbocharger or the types of different duty to operate and distinguish easily. I hope in the future and the work might be useful to everyone. Thank you. So before we finish, let's explain about how the turbocharger of the e-booster works. First one, vehicle and engine running at a low load and constant speed. E-booster is inactive, which means that with the constant speed, the electric turbocharger won't be work. And second is when the driver put accelerator instantly, the response and the boost provide immediately. You can see the color here, the amount of air get in compared to the last one. This one can see the intensity of the air go to the turbocharger and go to the bypass valve by the e-booster, and this one go to the intercooler. That one is the driver continually to extract the throttle more faster and faster. The amount of air getting higher and higher, and the car will go faster. And this step, the turbocharger take over, providing higher booster than e-booster is switching off. This is the e-booster, and this one is the electric turbocharger. Okay, that's it. Thank you for your attention. I hope this will be useful to everyone. Thank you. ขอบคุณครับ